Thermodynamics, literally speaking, concerns itself with the flow of heat and conversion of heat into work. Heat, as we all know, is a form of energy, and now the thermodynamics is actually concerned not only about transformation of heat into work and vice versa, but also it is concerned with all types of interconversion of one kind of energy into another, like electrical energy into work, chemical energy into electrical energy, etc. It is based on three simple but empirically derived laws of nature. Now, if we apply some mathematical tools on these laws of nature, and also on the other hand, if we have mathematical expressions of various physical properties of matter, then we can arrive some various interrelationships between various properties of matter, such as there may be relationship among pressure, temperature, specific heat, coefficients of expansion, latent heat, etc. Thermodynamics basically is concerned about the macroscopic or bulk properties of the matter. It does not tell about microscopic properties of the matter. Like from kinetic theory of gas, we know pressure is actually dependent on the momentum and frequency by which gas molecules heat on the wall, like this. But thermodynamics does not concern on all this. It only know that pressure is a state property of the matter. Simply, it is a state property. Likewise, temperature, in terms of kinetic theory of gas, we say that it is actually average kinetic energy of the gas molecules. But with respect to thermodynamics, temperature is actually only a simple property of the state of the matter. So, thermodynamics is actually a macroscopic property. It is no way concerned about the microscopic constituent, microscopic nitty-gritty of the matter. But there is another part which correlate between this macroscopic or classical thermodynamics and the microscopic property. These things are dealt with another branch of science, that is called statistical thermodynamics or statistical mechanics. So, thermodynamics is actually a macroscopic property, and it is about the interconversion of energy from one energy to another energy. How far a conversion will happen, whether an energy conversion will happen or not, how it will happen, this kind of answers we get from the thermodynamics. Next is Zeroth law of thermodynamics. Before diving into the ocean of thermodynamics, we should restate the Zeroth law of thermodynamics. Zeroth law of thermodynamics states that if two systems in thermal equilibrium with a third one, then they will be in thermal equilibrium with each other. This is, we have known this law for long, maybe from our school studies. So this law gives rise to the concept of temperature, and it also quantifies the temperature. If two states are in thermal equilibrium, then we say that the two states have same temperature. Now we take any arbitrary mutually agreeable state as a reference, gives a reference temperature and gives some arbitrary value to the temperature of that state, and from there we start quantifying temperature with respect to that reference state. In this way we quantify temperature. Like we state the boiling point of pure water at 1 atmospheric pressure as of temperature 100 degree centigrade, and with respect to that state we quantify all other states temperature.